All right. We are back, and it is COMP123. It's programming 2, and it's summer 2016. It's week 4, part 4 of our broadcast. We just finished talking about lists, which is kind of a little bit off topic, but not really, because there's still lists or complex objects that we can create through the list class. And remember, we're talking about classes and objects here. So last week we talked about classes. This type we're talking about inheritance a little bit. And we're going to continue to talk about inheritance next week too. I don't want to overload you with the idea of inheritance. The one thing I want you to take away again is that when I inherit something, I'm actually extending the parent class and I'm making it bigger. I'm adding things to the class, right? But we also still need to understand what classes are. And classes are blueprints that allow us to do stuff. So a list is a class, right? And we want to use a built-in class. So what we're going to do here is going to make a new kind of object. Let's do this. I'm just going to close the program class down for a second, okay? The driver class. I'm going to close this down. And we're going to make a new object to play with, okay? Just for playing purposes. Let me just do this here for you. By the way, you might see this in a future exam in another course, because by the way, the idea of the card class idea, card shuffling, and all that kind of stuff is a very common way of teaching object-oriented programming. So you may see it somewhere else. Let's talk about it. So in Solution Explorer, I want to create a new class, right? So add a new class. This is good practice for you to try this out with me, right? New class. And I want to call this class card with a capital C, the card class. So let's define the card class as a singleton. It's not going to inherit from anything else, okay? My card class is a singleton. All right. Let's talk about a couple of things here, right? A couple of things. And it's important for us to know these things when we talk about them. One, my card class is going to have 2 private instance variables, right? So I'm going to talk about what they are. Actually, let's use the auto property thing for today, okay? A little bit different than what we did before. So if I go prop in C#, and if I go tab, and I get something called this auto-generated property with the getter and the setter. Right? I don't have to use private instance variables here. I only have public properties in my class. That's totally acceptable. And it's a really quick way of making a simple class like this, when I'm not going to really add in anything else into my properties. Okay, if I want to extend them, I could always do that, but I don't need to. All right? So here's my public property. It has both a getter and a setter, and behind the scenes, it also holds data, right? So now let's talk about what this public property is. I want to call, they're going to both be string types, right? And my first property name is going to be what? Value, right? Card value or card face. You know, so there's going to be the actual face of the card, which is going to be the 1, 2, 3, 4, 5, ace 1, 2, 3, because it can also be an ace, right? Ace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King. Those are all the type of values that you can add to there, right? Okay. Let's think about this carefully now. Now there's some specialized values that I have in here for my property. For now, let's just call them faces. So this is like a face value, right? And notice that I'm making it face with a lowercase f. I want to make it face with a capital F. And I'm going to go to the next public property. So for public properties, again, we just put prop, right? So property. And notice I also have other ones too. Like I have this one, right? But I want to use this one. So the next one is going to be also a string type, right? And instead of face, it's going to be suit. Okay? So I have faces and suits. Okay, cool. That's what it takes. I'm not defining what those faces and suits are here. I'm just defining some properties. So when I have a card, when I create a card, right? Every time I create a card, right? When I instantiate a card object, I need to put in a face and a suit. That means I need a constructor to do that for me, right? So let's make the constructor. So here's my constructor. It's going to be called, if I go CC for constructor, that's that little shortcut that I got you guys to download, that little extension, that's that snippet, the extension pack, right? If we go tab, you're going to get a public card, right? Which is a constructor type, right? And what I'm going to put inside there is the 2 things I'm looking for. So I'm going to say string face and string suit in that order, right? So those are the 2 things. So a card takes both a face and a suit. Okay, there we go. in my faces and suits, I'm going to kind of do the assignment, right? I can do something like this. I'll say this face is equal to face. Remember that this keyword talks about this, the class context, this class. That's what this means. So I'm looking, when I use the this keyword, it's not this variable here, this local variable. It talks to the variable that belongs to the class when I use this, right? And I can also do this dot, suit with a capital S is equal to suit, the local variable that I'm getting into my constructor, this local variable here, right? So this local variable belongs to this, comes from the constructor, and this instance variable comes from my, or not, actually it's not instance, it's a property that belongs to my class. And when I do a class like this, I want to label it a little differently, right? I want to say these are my public properties. Notice I don't have any private instance variables. Public properties. There we go. These are all public properties with the auto property initializer, right? They auto generate properties like this, right? This is the syntax to do that, right? And then I use down here, right, a constructor. All right, so this is my constructor. Let's do the constructor commenting now. So we're going to do special comments for the constructor. So this is the constructor method. We're going to use a summary. And inside my summary, I'm going to put in a little description. So this constructor, it takes 2 parameters, face and suit, to create or to instantiate a card object. So it does, right? And then, of course, I'm going to put that in there. I'm going to say at constructor. My comment style is card. And at param, right, is, there's 2. There's a string parameter, which is a face. And at param, there's a string parameter that's also a suit. Those are the 2 things that it takes, right? And also my class, I probably want to document my class, so I want to do the same thing. My class type, right? So I'm going to these. And when I start typing, I'm going to start doing the same thing. Here's my class summary. What is this class? This class creates an object that represents a playing card. Right? All it does. Okay, cool. So we've got this idea. By the way, we can really build on this more than what it is. This is very simple what I'm doing. Right? And I can put my comments in here. I can do something like, sorry, I'm in your way. I can do something like at class card. Right? It doesn't take any parameters. Make that a little bigger if I get out of your way here. Right? So that's what I'm doing for the comments, right? So I've got this class as an example, right? And the class, what it's doing is I've got stuff in here, that is allowing me, to define 2 public properties and 1 constructor right here. And this constructor is going to, when I create my class, my card objects, right? It's going to initialize each of my properties, right? My face and suit of each card. Right? Make sense? Okay, so therefore, when I make a deck of cards, it's actually a list of type card. Card is going to be the type. I'm defining the data type right here, right? I'm going to use a list with a custom type, like I did before, of card. Okay. Now, here's something that we can also think about too. Right? Face right now is string, but face only has a limited amount of options for faces. I can do ace, right? I can't do a 1 because ace is a different value, right? So I really can do a number between, really each suit, I don't know if you guys don't know cards very well, each suit has 13 cards from labeled or numbered from 1 to 13. Number 1 is the ace. And number 13 is the king, right? That's what they are. Okay, so if that's true, I'm just putting it out there. I can use an enum, right? An enumeration is what it's called, to give me a friendly name to define each of my cards. All right, they're still numbers, right? But it's a friendly name. Now, I would have to change it from a string, right, to an enum type. A string. It's a type of integer, if you will. So what is an enum? Let's talk about an enum type before we end for the day, right? So we're gonna get back to this. So I love this little animated GIF. Just tells you everything. You guys can look at this later on. And you're like, if you don't get this, by the way, take a look at it on the video again. You'll see what it does. What it's really talking about. Pass by reference, pass by value. It's kind of cool. One of my colleagues sent it to me. But an enum, if I was going to look up what an enum is, if I go enum C#, right? What is that? It's always documented. You can find almost anything about any class. If you want to find out about the list class we talked about, MSDN online has this C# reference, right? It also, there's different types. You can see there's enum and enumeration types is what I'm talking about here, right? And there's also some examples, other places you can look to see examples. Let's take a look at the enum, what that is, right? It's another kind of type. An example of an enum is a keyword. You define an enum of type days. Okay, here's the type days. So I can define an enum of type faces if I want to, right? So here's my enum of type days. Just bear with me while I do this, right? Days, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Each enumeration has an integer value in the background starting at 0. So these, Saturday represents day 0, and then Friday represents day 1. If you want to start Saturday at day 1, you initialize it here inside the declaration. So you say Saturday is now 1, so now it's 1, 2, 3, 4, 5, 6, 7 days of the week, right? What do? Is they give us a friendly name of talking about the days. And I can do something like this, right? Notice how, by the way, you can put in, here's something interesting. You can actually go into, instead of just integers, you can go to bytes and other kinds of things too. So, okay. So now I can reference it like this. Once I have an enum, I can do something like this. Int x is equal to, and you have to convert it to an integer, days dot sun. So days would be your enum, face dot ace, face dot 2, face dot 3. And I would use the words 2, 3, 4, 5, 6, 7, 8, 9, 10, as opposed to the number 1, 2, 3, 4, 5, 6, and all those kind of things, right? That's how you can do enums, right? And here's some examples of enums, right? So you have an enum, days. I declare the enum first, just like a variable, right? And then what I do is I utilize it here. So I can say, well, I don't know what Sunday is, but I want to get Sunday. And then so I can always use Sunday. So it's a friendly way of doing it instead of like, day 1, day 2, day 3. You don't know what day 1, day 2, day 3 stands for. It's more contextual to use it because then when we read the code, we know what we mean. We mean 1, 2, 3, 4, 5, right? But we don't want to know the actual number. We just want to know the nice way of looking at it, like Sunday, Monday, Tuesday, Wednesday, Thursday. That makes more sense to us. We read stuff like that more. Makes more of an example. Sometimes enums can be confusing though, right? But it could be something that we want to use. Let's look at another example of enums. This, by the way, is bred up on Microsoft, right? Here's enumeration types. They also give you another example here. And this is Visual Studio 2015, so this is kind of an updated version. So again, I have enumeration, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? Again, they all start at 0. And then what I can do with enumerations is do something like this, right? Again, I can cast it as today. I can say days, here's days. I can make what we'll call an alias for the days called today, right? Is equal to days Monday. So today is Monday. Today is a enum type. It's like a string or an integer or whatever it's going to be. And I'm taking Monday, Tuesday, Wednesday, Thursday, Friday, right? So I can combine this, if I really want to, and make it a real complex card that has an enumeration of faces between ace, so a special counting way, ace and king, as opposed to 1 and 13. I can go ace, 2, 3, 4, 5, 6, 7, 8, 9, 10 in words, right? Jack, queen, king. I can do that. And then ace will have its own value. It may not be the number 1. It could be either ace as a 1 or ace as a 14, because sometimes ace is the biggest number in the deck, right? Okay, just putting it out there because cards are complex. You can remember we're kind of trying to create business rules to surround something that exists in real life. That's what we're trying to do here. Okay. All right, let's go back to make our deck of cards more of a simple way. But I wanted to introduce enums to you. We will be using them in simple examples because sometimes they're more descriptive for us and it limits our choices, right? Then if we were to use, it's almost like think about them as constants. Like another way to look at enums is like a group of constants, named constants that I want to use over and over again. Hey, here's something. If I want to use constants in my faces, could I do that? I could. I can have a group of constants, and I got to choose one of those constants, right? That it's going to be. I can create a class of faces, right? A face class, and I can incorporate my face class. So I have to use one of the values, right? I can do that. One of the constants that's inside the class. And it could be remember, a constant, when I declare a constant in a class, it's available to all objects that are made from that class. That's something new too. So an example of if I declare a constant anywhere in here, it's like a static. It exists, every single object that has that constant inside of it, right? Which is kind of weird, right? We're not going to go there right now. Let's just, I'm just trying to make it simple, a simple example. Then we're going to make this more complex later on. Okay, as we go, so we just get that. So we got our card class, all right? And what I want to do now is I want to make a list of cards called a deck, right? And let's do that. We're not going to do that here. We're going to do that in our program driver class, right? So we're going to kind of kill this. We're going to go back to our program class. So we're going to go into our Solution Explorer, and I'm going to pull out my program class here. And we'll leave everything the way we had it. Who cares? This is just examples, so you guys can always go back to lesson 4. This is just for lesson 4 stuff. And go back here and take a look at this, right? So if I go back to the bottom after I've done this funky one, this class, I use this names list. I want to do another list called deck, right? So we're going to declare a list of type card. That's what deck is. So list, that's how we do it, of type card, right? List of type card. I'll make this really big for you guys to see it. So list of type card, that's the first thing we do. And we're going to call it deck. Okay? So it's a deck of cards, right? Right now my deck is empty, right? It's a container. I have to add the new keyword because I'm declaring a new list of type card. Follow me here. Follow me here. You'll understand what I'm talking about one day. Right? All right, so now that I've done this, this is nice, but I somehow have to load all the cards into the list. I can't just, now my deck is empty. It's just like, I called it a deck, but really in real life it's just an empty container, right? Which doesn't really go with our ideas of how we want to. Our business rules don't make sense right now. So how do I load cards into the deck? Let's make a method. Now right now we have this big method called main. Let's make another public static method that returns void, right? So we'll do that. And what we're going to do with it is we're going to pass in a reference to my new list, this deck list. We're going to pass the deck into the method, right? And remember, because a deck, what kind is it? Is it a value type or is it a reference type? Objects are always value type, reference types, right? So when I pass a whole object into a method, right? I pass a reference. Okay. So let's make our new method. So I'm going to say public static void for now, and we're going to call this stack the deck. We're going to call the method. We're going to stack the deck, right? Or that doesn't make it. That's actually misleading. We'll say create deck. How about that? Create deck. Like create deck method. Okay, what do I have to pass into it? I have to pass my deck. What type of data type? What data type is my deck? It's a list of cards. That's what it is. That's what I have to do. So a list of card is what I want to pass in there, right? And I'm going to pass in my deck, which is in lowercase. I'm going to call it my local name for it. It's going to be called deck. Whew, right? Okay, here's something. Create deck says inconsistent accessibility parameters, right? List card is less accessible than method program create list card. What does that mean? Well, because list card is I've put it here inside my public static method, right? And I'm trying to make it accessible outside my public static method. So what I need to do up here, I got to declare list card way up here, right? Let's try this out. So I need to do something like this: public static. Gotta be careful when I do this. Then I got to go down here and grab my list card. So I'm going to kind of cut it out. Because list, as an example, it says create deck, right? But list card, list card deck is kind of totally different. So I'm going to cut it out. See if this is going to do the same. We're going to fix me. Right, so I cut it out, and I go up here, right? And I put it up here, and I go one of these. Would this fix it? Public static list card deck. Whoa. Inconsistent accessibility field. List card is less accessible than field program deck. What does it mean? How come I can't do it? Right? There's a new list card. I can normally do that kind of stuff. And it says the same thing here. Look, create deck list card. No? You're not getting the error? Are you getting the error? You're getting the error? Sometimes what we need to do is clean our solution. Sometimes we need to do that. And sometimes what we need to do is rebuild our solution. Sometimes we need to do that. But you see, inconsistent accessibility for fields, less accessible than the other. Did you get the error? You getting the error now? Okay. So, so what does this error mean? Inconsistent accessibility, right? Because it says deck inconsistent accessibility field type list card is less accessible than field program.deck, right? Program.deck. So program.deck. Do I have a deck somewhere that I've defined, right? Well, no, right? But I'm making it public static, right? So if I just make it public by itself, it's not going to do anything, right? So I can't make it public by itself, right? And when I declare it here, if I was trying to declare it outside my, how about if I declare a variable outside here, like inside my class but outside my main? How do I do that inside my driver class before I let you guys go? And we'll complete this next week. So let's say it's not a public card deck. I'm gonna take this out for a second. Okay, so I want to kind of remove it. Let's remove this for a second. And let's put it back where it was, which is down here. It was working fine in here, right? But it wasn't public deck, right? I mean, it was just list deck, like this, right? So this didn't give me a problem. When I was in here, I was golden, right? But once I created a public static create deck and I passed in a list of card, right? All of a sudden, I'm getting an error, right? And how come I'm getting this error, this public static option down here, right? It's inside my, am I putting it in the wrong location? It's still supposed to be inside my public class, but I'm just making another method. What if I didn't pass list card? If I pass something else like string, hello, right? That works. But when I pass my list card in there, I got an error, right? How come this is happening? Well, let's take a look, right? And what's the access modifier for list? No. So if I go back to my my solution explorer, this is just something for you guys to think about. I want to leave this with you. So I go back to card, right? Here's something. Card, is it public or private? I didn't declare it, right? So undeclared means private. So if I go public, right? Unless I make it public, guess what I get? I get no access. So my card has to be public, right? And also, not just my my constructor, but also my class. If I don't declare a public class, right, then it's not accessible. It's private or protected, right? So now let's go back and see if it fixes my problem, right? Remember? Okay, now let's quickly do it. So when I create my deck, what do I want to do? I want to iterate through the entire card. I want to create a for loop, right, somehow. And for now, my faces, I want to make special faces, right? But let's make one change, okay? Just one change to the card class to make it easier for us to digest. Let's make it so that the face is actually an integer, 1 to 13, right? From an iteration perspective, let's just say, right? Just to make it easier for us to iterate. Otherwise, it's going to take us time to build the whole thing. And we have to go now because we're timing out, right? So if I go back to my my Solution Explorer and I want to modify my card class, and instead of it being string suit, let's make it, or string face, let's make it an int face. And then we have to change this card, this string face in here as well. Right? Just one thing different. That's why, so that way we're all good. Okay. So I've made some changes here so that my card is of type int and so on. Now if I go here, for example, and I want to make my list happen, I want to do this. I want to say list. I want to pass in a type card. I'm going to call it deck. Right. So this is where I'm passing in. I'm passing in a deck of cards in here. And here's my list that I'm making out here. So what I'm going to do here is I'm going to call my deck. Right. I'm going to pass my deck into my create deck, and it's going to create it. Right. So how I'm going to do that? I'm going to do one of these. I'm going to say create deck in here, and I'm going to pass in my deck, capital D, right? So I'm passing in a reference to my deck inside my create deck method, which is right here. My create deck method is going to access my deck, and I'm going to do a for loop to do that. Now I know I need 13 cards in my faces, so I can do 2 for loops. Here's one, if I want to. Actually, I just make a for like this, and I'll say, and this I'll call this index, right? So, and here's the length. I know that it's got to be 13. From 0 to 13? No. It's got to be starting at 1. So I don't have no 0 values in my deck. It's got to be 1 to 4 and less than 14, right? So, so it goes from 1 to 14. Now, inside there, I want to do something like this. I want to say my deck, lowercase d, right, dot add, because it's a list, you know, and I want to add it where? Into my card item. Right, so it's a card item, a new card. Here's my new card, right? And what card is it? Because I'm adding in a new card, and the new card takes 2 things: faces and suits. So I can satisfy my first one with my my for loop. My first one is the faces, which is 1 to 14, right? 1 to 13. So I pass in an index. Okay, but that doesn't satisfy my second parameter, which is my suit. How do I pass in my suits? Well, I got to make a string, and every time I increase the number from 1 to 4, depending on which number it is, if it's 1, it's as an example, it's hearts, and the next one is clubs, and the next one is, and so on. I can pass it in, so depending on what the number is. And I can check for that, right? Okay, cool. Hold on a second. Bear with me. So now I have another for loop out here. So 4, and I have another integer, let's say, as an example, and I start at 1, and I go to less than, or it doesn't matter, 0 to 4 is fine. 0 to 4, because it doesn't matter. 0 to 4, and inside these 4 suits, I have my suits, right? So I say, and I declare a suit variable. Here's how I'm constructing it. So here's my suit variable. So string suit, right, is equal to whatever. In the beginning, it's nothing. It's just an empty variable. But inside my suit, I say if my number is 1. So if I, right, is equal to 1. Well, if I is equal to 1, 2, 3, 4, I'm better off doing case, right? Now, you guys, I'm going to time out, guys. I'm sorry. They're probably waiting outside for me. If I do switch, here's switch. Here's my switch. Switch I, and I is a very bad thing to use, but let's just use it for a second so I can finish this off. Case 0, right? Then suit is equal to hearts, let's say, as an example, right? And then break. And then if I do the next one, I'll do the next one and the next one, and the next one really quickly. This is one way of doing it, by the way, and there's many other ways that are far easier and better than this. But let's say case 1, right? Then, if I can probably spell it properly, then this one would be hearts, clubs, and this one would be diamonds, and this one would be spades. Those are the suits, right, inside of our deck. This one is 2. This one is 3. All right, so this is our for loop, and we're switching. Depending on what it is, we're going to change the hearts, clubs, diamonds, and spades, right? And we're going to put this, look at this. We're going to take this for loop and put it inside this for loop, like this. And so we're going to say this. It's going to start off at 0. And if it's 0, suit is going to be hearts. And we're going to pass in suit into here. We're going to change this one to call it to face. Be very careful not to modify anything. We're going to change this to face, and then face plus plus. And now what we have is, here's our suit. And here's something. How come I can't access suit, string suit, from up here, right? Because it should work. I mean, card is suit, and we're getting a bunch of suits. It says use of unassigned local variable suit, right? I'm kind of putting it in here, and I'm assigning it here. Well, I got to give it some basic values, what it's really saying, right? If I don't do that, then it'll give me an error, right? Maybe I won't go through the switch statement, is what C# is worried about, right? And now what I've got, my ladies and gentlemen, is I've got a way of creating my deck, right? Because I'm going to go through, and depending on what the number is, 0, 1, 2, 3, I'm going to load the suit into this, and it's only going to iterate once. So it's going to go through this, right? It's going to finish its 14 cards, right? Or 13 cards. Then it's going to go back up to this for loop, and it's going to increase this number, right? And it's going to go to the next one, clubs, diamonds, and spades. So I'm going to have something like this, a 1 of hearts, a 2 of hearts, a 3 of hearts, a 4 of hearts, all the time. I'm going to add them all into the whole into my deck, and my whole deck is going to have 52 cards loaded into it. Let's take this up next day when I come back we're going to see each other on Tuesday, and we'll continue with this whole deck example. And we'll start interfaces and polymorphism and all that kind of stuff. Thank you for your patience.